Imagine you're in the water. There's a warm current swirling around you, whipping through your hair like the wind. And you look down. There's a vast reef community that spans the entire sea floor. Zooming in, you look at the biodiversity. It's great. It's large. There are fish swimming around, chasing each other, working their way in their food webs, in their jobs, in the food chain. And you look around some more. Zooming in on the rocks, you see shellfish, you see nautiluses, and you look up the sky. You peep out of the water. You look towards the coast. Are those plants you see? Maybe. You zoom in more. Are those insects you see? Maybe. Well, if you want to know, stay and listen to me. Talk about the Silurian period. Yeah. Welcome back to Bones et al. And after that musical break for like, I don't know, 10 seconds, we're talking about the Silurian period. Yeah, right after the Ordovician. Silurian is like a little transitional period, I like to call it. It's going from the Ordovician, from the last episode, the Great Ordovician Extinction event, I think. I'm not sure. G-O something. G-O... Hold on. Oh, there we go. LOME. I remember. It was 2 weeks ago. Anyways, I've kept my promise. I said I'd come back 2 weeks later. I am back. Hello. So today, the Silurian period. Just as I said, it's a transition period and is the shortest period of the Paleozoic era. Teensy weensy. It lasted from 438 million years ago to 400 and wait, hold on. Did I say 438 million years ago? Because I don't remember what I just said. To 408 million years ago. So 300 million year span. And that's not a lot. That is not a lot. So following like the LOME, Late Ordovician Mass Extinction, I think. Yes, it is. During that, after that, in the Silurian, reefs developed. I said vast reef communities. Yeah, they grew practically. There were specifically tabulate stone reefs, which consisted of tabulate corals, colonial rugose corals. I can't speak today. And stromatopod sponges. The one thing about sponges is they're rock. I cannot understand how they are living. I mean, I'm pretty sure they do go through the processes of life. Like, what are they? Movement, respiration, sensitivity, and then growth, reproduction, excretion, and nutrition. I think they definitely do. So they live. Whereas viruses don't, because they don't respire. Yeah. Anyways, so since the Ordovician, LOME, it's one of the big 5 mass extinction events. Anyways, since the Ordovician, the reef communities became more complex and diverse. than those from the Cambrian and Ordovician periods. So, yeah, big improvement. They went to the App Store and upgraded it. Practically, sorry. However, unlike the simple Cambrian reefs, the Silurian reefs consisted of a vast array of animals and algae. So, I'm gonna add into this with my biology GCSE knowledge and some of my geography knowledge, because I love biology and geography, even though they don't seem like they are compatible, but I love them. Anyways, on the human side, they aren't compatible on the human side sometimes. Sorry. Continuing on. Algae, feeds plankton, it does. And then the plankton gets eaten by, more fish. Those fish get eaten by bigger fish. So, algae are the primary producers. They get eaten by the primary consumers, and then the secondary, and then the tertiary. Tertiaries, not an apex predator, top of the food chain, top of the food web. I don't think I've yet to meet an apex. No, I've seen apex predators. Anyways, big development, kind of developed how our reefs are today. And not only do they have large biodiversity, but they were pretty tall. Yeah, many individual reefs rose about 40 feet above the seafloor. And I'm not very familiar with the imperial system. So 40 feet in meters. 40 feet in meters. Whoa! 12.2 meters, essentially. Jesus. Okay. I would not... Well, I would want to go snorkeling around there. But, yeah. Anyways, not only did they rise above, emphasis on above 40 feet, so above 12.2 meters, but they also spanned many miles. So, yeah. I would have given everything to snorkel in this. Not that. I've been snorkeling once. It wasn't really fun. Water kept getting in my goggles. Anyways, reef communities, believe it or not, well, obviously, believe it, wait, hold on, I'm not reading. We're not the only new forms of life in the Silurian. So other stuff developed too. For example, many of the surviving species from the LOME, Late Ordovician Mass Extinction event, I'm not actually going to recap, that'd be too long, were adapted to cold water from higher latitudes or deeper waters. I would also like to, let me finish this point first, and then I'll bring in my knowledge. Therefore, diversity of marine invertebrates during the early Silurian was low. So, it was pretty lonely. I don't think you would have wanted to be in the early Silurian, but by the late Silurian, communities of marine invertebrates became comparable to that of, during the Ordovician. So, I took this from a research paper, and I think what they're saying is, that it grew so much bigger and better than the Ordovician. I forgot what I was gonna say about my special point that I was gonna make. Anyways, continuing on. Oh, yes, brachiopods. Remember the brachiopods I was talking about They were like, I think I described them as scallops. They do look like scallops, but I think I was inaccurate. They look more like clams. Yeah, I don't really like clams. Anyways, brachiopods, bryozoans, corals, crinoids, and graphtolites, which return to the Silurian seas, were represented by different families and orders compared to those from the Ordovician seas. And believe it or not, I'm gonna add my knowledge into this. That's right. So, like, many episodes ago, probably like 2 months ago, 1 month ago, I don't know. I was talking about the black moths of England after the Industrial Revolution. This is the same thing. If you're listening to this podcast in a sequence, then you know what I'm talking about. Just in case you don't know what I'm talking about, I will talk about it. So, for example, take I know, I have a new example. For example, there was a finch that went to the Galapagos Islands. And initially, it only went to one of those islands. But then, those birds went, oh, look at all those other islands, let me go there. So, some of them went and flew there. But then, those islands had like different types of food, different animals, different predators, different everything, different habitats, not different climates, obviously, but they were pretty different. Were they the Galapagos Islands? I think so. Correct me if I'm wrong, but I will continue with that. I am not a professor in any shape or form. But anyways, some of those birds right now, like, they've evolved to have different shapes of beaks, to have like bigger sizes for depending on metabolic rates, depending on what they eat. And this is all because some of the birds that migrate to these different islands had different variations, different, I don't want to say mutations because that sounds bad, but they had different sizes of beaks, different types of beaks, different aspects of them. And eventually, because the other birds that had but hold on, let me try and get my words straight. Some of the birds that had different sizes of beaks suited to the types of foods that were on those new islands. So they had a higher living, higher success rate. They were more likely to survive. So they were more likely to reproduce. They were more likely to pass their genes on to the next generation. And that generation would be more likely to pass on those genes to the next generation, And so, evolution. I'm thinking if it's Canary Islands or Galapagos Islands. I'm not sure. Please do correct me if I am wrong. Anyways, yeah. I'm hoping that made sense. But, natural selection. Darwin. We like Darwin. His book is funny. Some of it's funny. Some of it's a little bit questionable. But anyways, people like it. So I will keep my mouth shut until I'm officially a critic, which I don't think I'll be. Anyways, yeah, different families and orders compared to those from the Ordovician seas. If you still remember what I was talking about before that whole spiel about birds, I like birds. Thin-shelled Ordovician brachiopods were replaced by brachiopods with thicker, more robust shells. So, from my understanding, and I'm not saying this is scientifically correct, take it with a large grain of salt, probably. Like a cup of salt. 100 grams of salt. I don't know what measurements you use. But I'm thinking evolution to warmer seas, because all the signs point to warmer seas, I think. Greater biodiversity, larger coral reefs, but not like warmer seas to a higher extent. Otherwise, the coral reefs would bleach and stuff, like they are doing right now. Global warming is a real thing. Anyways, sorry. Yeah, so the ones that had thinner shells were just pushed out because they were less likely to survive. Hence, natural selection by Charles Darwin. Yeah. For example, and I'm building on, the brachiopods being, like, the thinner shelled ones being pushed out. How do you pronounce that? Pentamerids, sorry, or the most characteristic brachiopod. So, probably the most vivid. I'm just wording things differently. Sorry. During the Silurian. So, the most recognizable one during the Silurian. They were in dense communal clusters and were really important to reef communities. But they were also soon replaced by other brachiopods during the Devonian. And I think, because then again, I took this from a research paper. I wrote down the notes. I'm just building on those notes. It said that they were really important to the reef communities. And, I mean, what do mollusks do? Like, mussels, clams, scallops. What do they do these days? Well, what do you mean these days? They've done this for ages. Anyways, what do? They filter out the water. So, I'm guessing that's what they're referring to, but take it with 1,000 kilograms of salt. I am not sure. I am not very sure. Please take it with 1,000 grains of salt. 1,000 grams of salt, 1,000 kilograms of salt. I don't know. My input. Anyways, bivalves and gastropods were also outnumbered by brachiopods. And yeah, brachiopods were the thing back then. To put it plainly, they were the fur coats of today. I like maybe I wouldn't. Anyways, sorry. Inner monologue. Yeah, brachiopods, I mean, they were it then. They aren't it now. They have very few species, but they are still here. So I would take that as a win for them. So, yeah. Bivalves, however, were evolved to live in freshwater environments. So, I mean, we're talking about the seas here. So they were pushed out the marine ecosystem into freshwater ecosystems. So, win-lose situation here. Yeah. However, the trilobites were declining. Yes, it is sad. Trilobites were declining. The scarcity of the trilobite fossils found during the Silurian period, and this may be because, I don't know, we haven't found a lot of them yet, because they're they're at an undisclosed location. That's a possibility, but I'm not sure. Take it with a grain of salt. Where was I? Yeah. Shown that they were also declining with the nautiloids. The nautiloids are also going. Yeah. Say bye. I love Nautilus. I mean, the Nautilus is still here today, which honestly I am surprised. But natural selection, I guess they were too successful. I guess they were too adapted. Charles Darwin, emphasizing that, sorry. Anyways, the nautiloids remained a major predator until they were replaced by ammonites in the Devonian. Yeah, as I said before, the only nautiloid remaining today is a nautilus. Building on what I said a couple episodes back, I would buy a nautilus plushie. I would. I definitely would. They're cute. I like them. Anyways, other than nautiloids, there were also other major predators. The Euteriptids. Nailed that. They were arthropods. Yeah, arthropods. Related to modern scorpions. So, marine scorpion, if you must. Did you actually know that they're like diving spiders? Sorry to people who have arachnophobia, but diving spiders, like, they're crazy. Anyways, and the spiders that do extreme sport. I'm sorry. Anyways, where was I? Yes, modern scorpions. I have yet to. I think I've seen a scorpion. I've just yet to see one in the wild. I've seen a few in zoos. And they were okay looking. Anyways, armed with claws, front appendages. So, regular scorpions. Yeah, they looked the creepy crawlies. Anyways, to hold down prey, to like pin down the prey, you know? Most were small, being less than 20 inches in length. Well, hold on, less than 20 inches in length. That is not small. I retract my statement about it being small. That is not small. That is more than a foot. Oh, but one specimen reached 9 feet. Oh, I don't like that. I like all animals. Some just don't make that boundary. I'm getting goosebumps. I don't like it. I don't like it. Yeah. I don't know what the research paper was saying. Most were small, being less than 20 inches in length. Girl, that is not small. That is big. That is big. However, one specimen reached 9 feet. You can't scare me like that. Anyways, although present throughout the Paleozoic era, I can't pronounce it again. Euteriptids. Anyways, Euteriptids reached their peak in the Silurian. So, they peaked in in a duration of 30 million years and just dwindled down. But guess where they went? On land. I will get to that soon. Yeah. Planktonic forms also thrived in Silurian waters, believe it or not. Yeah, obviously believe it. We still have them, and I talked about them a couple of episodes ago. So, believe it. Definitely believe it. Yeah. By late Silurian, graphtolites were in their final days, so they were on their deathbed. Short after the end of Silurian, almost all the graphtolites became extinct. However, except for one species, which, honestly, was a trooper. It stayed until the Carboniferous. Like, okay. Stay. Damn. Okay. Another great advancement in marine life during the Silurian were marine vertebrates. And this was like the beginning of an improvement. You know what I said, like a 30 million year gap of transition until the Devonian. Devonian is where everything shoots up, kind of. Anyways, although jawless fish have been around since Cambrian period. Cambrian period, crazy. I would not want to live in that. They began a significant evolution, like, during the late Silurian and Devonian. I have to say, Devonian is, like, my favorite era. I love the Devonian. It's delicious. Excuse me. But the lack of jaws implicated, like, the lack of jaws in the fish during the Silurian implicated that they were filter feeders, and the development of head and body armor suggested that they were prey. Development of head and body armor. Guess where that's from as well. Guess where? Natural Selection by Charles Darwin. Yeah. Anyways, the Silurian included the first appearance of jawed fish. I don't think I can pronounce that. Acanthodians. Acanthodians. Oh, no, that sounds so wrong. Acanthodons. Yeah. Large eyes and a jaw contributed to their success as predators. So large eyes could see well in the dark. Yeah. More light waves could enter their retina. Could enter the cornea, hit the retina. They could see more. And jaw. Nom nom. Sorry. Until the Ordovician, only the edges of coast. Now we're going on land. We are going on land. Until the Ordovician, only the edges of coastal land were dominated by plant life. From what I remember, I think I said, like, vascular plants. Like, they looked like jugs. Recent discovery of fossil spores suggested that by the late Ordovician, advanced plants were actually already present on land. So this disproves my last, it contradicts my last episode, and I am embracing that. Advanced plants were apparently on land by then, but we have no idea what they look like, because there's no fossil record of them. But they are fossil spores. So, yeah. The first plant which invaded the Silurian were they vascular plants in the Ordovician? Am I going crazy? Allow me to check. I am so sorry. No. What? Yes? Okay, hold on. I'm recapping a bit from my Ordovician notes. Terrestrial plant derived cryptospores from bryophyte-like plants became widespread during the Middle Ordovician, creating a bryophytic landscape. In quotation marks. Now, back to Silurian. The first plant which invaded land were vascular plants. I retract my past statement. I am sorry. I cannot pronounce that. Oh, let me try. Hold on. Risk-taking. Yes. Sorry. Examples include Baragwanthia longfolia, and Cooksonia caledonica. Butchered that. Nailed it. Yeah. Now, remember when I talked about insects and what's on the land in an intro? the Silurian also hosts a possibility, emphasis on possibility, likely but not likely, of the first forms of animals on land. Possibly the first land animals were scorpions and millipedes. I don't know if a lot of people know this, but millipedes are actually is it toxic or poisonous? Under threat, they will secrete something that is harmful. And I don't like that. So, I don't like millipedes and centipedes. I'm fine with spiders. I just can't with them. With millipedes, centipedes. Scorpions, if I avoid you, you're fine. Don't come near me. Don't go in my shoes. Leave me alone and you're fine. Oh, sorry. Yeah, they were found in rocks, so fossils of them. Scorpion, so scorpions are old. Scorpions are, they're old. They appear to be descendants of the Euteriptids, but they also look alike to the modern scorpion. I am a bit freaked out about that. 9 feet long. I don't like that. In the sea as well. I don't like that. Anyways, that is all I have. Thank you for listening to me ramble about the Silurian. Next week we talk about the Devonian. I love the Devonian, and you should too because it's exciting. Let me and I've got long notes on this. Long notes. Very long notes. You should be excited. Yeah, you should. You should, because you're learning. Yeah, who doesn't like to learn? Okay. Thank you for listening in. I hope you liked it. I hope you could bear my rambling, and I hope you tune in for next week. And this is also on Spotify. I'm trying to figure out iTunes. And if you liked this episode, follow from the start. You'll and especially listen to the introduction to it, cause you'll get a lot of context. Yeah. Okay. Thank you. Thanks for listening. I hope you join in next week. Bye.